and gentlemen, today we are talking about section 6.4. We're proving triangles similar by AA, which stands for angle-angle. Don't let the title of this section frighten you. We're not actually doing formal two-column proofs any longer, but you will still be asked to explain your answers and give justifications for things that you say. So we're going to start with the postulate, which is the only postulate we'll talk about today, and the whole lesson is centered around this, the angle-angle, or the AA Similarity Postulate. It states that if two angles of one triangle are congruent to two angles of another, then the triangles are similar. So here we have one pair of congruent angles, and we have two pairs. Now the way that this works is if I know that the first two pairs are congruent, I know the third pair is, by the third angles theorem. But I don't have any way of checking proportionality here. Well, that's where the fact this is a postulate comes in. It's a postulate which is based upon fact. There is no proof for this. There's nothing I can show you to prove it to you, although we did do the activity in class which should have shown you that anytime the angles are congruent, automatically the sides will be proportional. The fact that the angles are congruent in both shapes maintains the shape. So since all the angles are congruent, the two figures will always be the same shape. Might be different sizes, but the fact that the angles are the same makes the shapes the same. But let's use this postulate for some example problems here. We're going to determine whether the triangles are similar. If they are, write a similarity statement. We will explain our reasoning. I'm going to explain it verbally instead of writing it out for the sake of making this video concise. So in this case, we have one pair of congruent angles. We have right angles. We know all right angles are congruent, so there's our first pair of angles. So for my first pair, I would say angle D is congruent to angle G because they are right angles. And then my other two angles don't match up, 26 and 64. One is obviously larger than the other. However, if I use my triangle sum theorem, 26 plus 90 plus E should give me 180, so E must be 64. That means that angle E is congruent to angle H. That's my second pair of angles. I'll say I use the triangle sum theorem. And so yes, they are by AA. To write a similarity statement, again, you just state that your first triangle, you can name it any sort of way you want to. I'll say CDE is similar to, using the tilde, your second triangle. Just make sure your letters match up. So C was 26, so that should be K over here. D was a right angle, so it must be G, and then H is my last one. Let's try another one. Show that the two triangles are similar. Show that. We are going to give some sort of justification, maybe not in a complete sentence, but we are going to give a justification here. So for A in triangle ACD for part A, we have one pair of angles that are 52, and we're looking for a second angle. So our first one, I'll say, was angle ABE. That was congruent to ACD. And that was given. The second one's going to be a little bit tricky. There are two ways we can go about this. One is the quicker way, one is the more complex way. But I want to go through the complex way simply because it's nice to investigate these properties and review some things. Well, these two angles here are 52, and they happen to be corresponding angles. If we look at this as our two lines and our transversal. Well, since corresponding angles are congruent, our lines are parallel. And since our lines are parallel, our other pair of corresponding angles are congruent here. So for our second one, we could say angle AEB is congruent to angle ADC. And I would say corresponding angles, something like that. That's the long way. The other option we had is that my smaller triangle, the orange one, and I'll make my larger triangle the red one, they both share an angle up here. So using the reflexive property, I could say angle A is congruent to angle A. And again, that's my reflexive property of congruence. So there's a couple ways you can do part A. In some problems, there are different ways you can do it where you still end up with the same solution. Just like a GPS takes you to the same place by different routes. this. All right, for part B, 2 more triangles. Well, first of all, we're given the fact these are parallel, so we're probably going to have to use that. So I'm going to say that angle R and angle T are congruent because they're alternate interiors. And if that's difficult to see, try extending your lines and then picking your transversal. And then I can kind of white out the stuff I'm not using here. And you can more easily see how those are alternate interiors. Different sides of our transversal on the inside of our parallel lines. So we can use that. Because of that, we can also say not only are those 2 alternate interiors, but also, sorry, just use that one, S and U. I can say the same thing. And there's my second pair of angles. If you wanted to, you could also use your vertical angles here, and that would be fine. So you could also say that angle SVR is congruent to angle UVT. You could choose any 2 of these 3 and use AA to say that these 2 triangles are congruent. So any of them that you wish, you can do however you pleased. And let's do one last problem. I love these shadow problems. So let's take a look at the picture and then we'll look at the problem. So let's say the sun is shining somewhere over here and it's shining down in this direction. Well, one property about the sun is that if 2 objects are in relatively close proximity, so this woman is pretty close to this flagpole, they're pretty close to each other. The sun is hitting them at the same angle. The sun rays will come down at the same, I'll draw this for now, same angle. So that's going to create a pair of similar triangles. If I were to connect the top of the head to the end of the shadow, if I were to connect the top of the flagpole to the end of the shadow, we have 2 triangles. This angle formed by the sunlight coming down, those 2 angles are going to be congruent. And that's because the sun is hitting them at the same angle. We also have right angles because naturally we construct things to be perpendicular to the ground. It has to do with gravity. So that means that these are similar triangles. We have 1 pair of angles and a second pair of angles. So since they are similar triangles, we know the sides are proportional. So what we can do with heights and shadows is, let's say we wanted to find the height of this flagpole. So that's x. Instead of actually measuring it and somehow getting to the top and measuring how tall it is, we can do something called indirect measurement, where we don't physically measure with a tape measure, but we can indirectly measure it using different properties from trigonometry or geometry. In this case, we're doing geometry. So we know the height of the woman is 5 feet, 4 inches, and her shadow is 40 inches. We also know the shadow of the flagpole is 50 feet. So we can use these to set a proportion to solve for x, because we know these triangles are similar by AA, so the sides are proportional. So if we were to write a proportion, let's compare the small height to the large height. And that should be proportional to comparing the small shadow to the large shadow. And we can cross multiply, solve for x, and we'll end up with the actual height of the flagpole without physically having to measure it. Now, let's make sure all these are in the same units though. We have feet and inches here, we have just inches, and we have just feet. So let's turn all of these into inches. If there are 12 inches in a foot, then 50 feet is actually 600 inches. 12 inches in a foot, so 5 times 12 is 60, plus the leftover 4 inches, that is 64 inches. Now all of our units are the same. Of course, that means our answer x will also be in inches. So let's cross multiply this. If we end up doing that, x will equal 960 inches. Or that's going to be 80 feet. So this flagpole is 80 feet tall. And you can do this with anything. It can be any sort of structure that is, we're trying to measure the height of it. We can use shadows and another known height, like the woman. So you can use your height, or the height of a car that you know, or something like that. The height of anything in its shadow, and the height of your unknown, and the length of its shadow. So It's an interesting application of similar shapes. We'll do some of this more when the weather is nice, and hopefully go outside and do some of that. But I hope this video is helpful. Feel free to email me if you have any questions.